In this lesson, we want to look at counting techniques. So our first objective is to understand how to use a tree diagram, to understand how to find a permutation, and to understand how to find a combination. Our vocabulary: tree diagram, showing possible outcomes using a branch for each choice. Permutation, arrangement where order matters. And combination, arrangement where order doesn't matter. So the first thing we're going to look at is the tree diagram. We're going to use an example of, at a restaurant, you are allowed to choose one of 2 entrees, one of 3 drinks, and one of 2 desserts. And then from this tree diagram, we're going to come away with a counting principle, basically a way to figure this stuff out a little bit faster. So we can choose one of 2 entrees. Doesn't really matter what they are. So what we're going to do is we're going to branch off. We've got 2 possibilities here. And then from there, we have 3 drink possibilities. Well, what you choose for an entree doesn't affect our drink possibilities, so there's 3 branches from each one of these. And then we get to the desserts, and there's 2 possible desserts. So from each one of these, we can branch again twice. So then from here, we can just count up how many ends there are, and that's the total number of possibilities. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Well, there's 12 possibilities. Now from this, hopefully we can see a pattern that we could take 2 times 3 times 2. And we would get 12 possible outcomes. Basically, what the counting principle says is that we can multiply all our possibilities together to get the possible number of outcomes. So it's A times B times C times ... because we could have 4 or 5 possible situations that happen. So we just multiply those and we'll get the total number of outcomes. Okay, this idea is based off of a permutation. So I've got another example. Say in our pocket we have 6 coins, each one being a different type of coin. $1, a half dollar, a quarter, a dime, a nickel, or a penny. If we pull 3 out at one at a time, and in a permutation, order matters. So what we want to know is what the permutation would be. Well, this N here represents the total number of possible things that can be pulled out. So this would be a 6. We're using a permutation that tells us that the order matters. So so a dollar, half dollar, quarter is different than a dollar, quarter, half dollar. Even though they're the same 3 coins, the order in which we pull them out matters in this case. The R represents how many times we're going to do this process. So we're going to do it 3 times. And then what that tells us is there are 6 possibilities. So that goes in the first one. This 3 tells us how many times we're going to do the problem. So we're going to do it 3 times. Then the 6 tells us what to start at, which is 6. After we pull 1 out, we don't have 6 anymore. We now have 5. After we pull 1 out, we don't have 5 anymore. We now have 4. So 6 times 5 times 4 gives gives us 120 different permutations, meaning that the order matters here. So there's 120 different ways where the order matters. A combination is the method where order doesn't matter. In this one, a dollar, half-dollar, quarter is the same as a dollar, quarter, half-dollar, because they're all the same things, but the order doesn't matter. So when you get the dollar doesn't matter as long as you get a dollar coin. So to do this one, again, our N and our R represent the same thing. So what we have is we have 6C3. And what this tells us in this situation is that we actually have to do two problems. The first problem we have to do is 6P3. So 3 permutations of 6 possibilities. And our other option is we always use the 3 twice. So 3P3. And then we're going to divide these. So the top one gives us 6 times 5 times 3. And the bottom one gives us 3 times 2 times 1. Oh, that's not a 3, that's a 4. 6, 5, 4. And this one gives us 3, 2, 1. On the top, we're going to get our 120 from the last problem. On the bottom, we're going to get 3 times 2 times 1 gives us 6. Then we divide at the end. So this one's telling us there are 20 combinations. And when we say combinations, we don't care about the order. So dollar, half-dollar, quarter is the same as dollar, quarter, half-dollar. Whereas in a permutation, the order matters. So that's why there are 120 different permutations, but only 20 different combinations. Okay, if there's any part of this that you didn't understand, please rewind, watch again, and bring any questions to class. Thank you.